Yeah, Ed Tiedemann spoke about challenges, and I realized when I saw this slot where I'm speaking after my colleagues and industry friends, Juho and Ed, I also see there is a challenge that I provide something interesting to you without repeating too much, but emphasizing certain points that you see the industry is working together and is also aligning. So bear with me, the slides will be a little bit less rich in information, so you have to listen to me at least for a good part of the presentation. So what is the state of the union on 6G? When I was thinking that, I was trying to think about a couple of elements. One is by this analogy we use often with the glass. Is it half full or is it half empty? So we see the geopolitics and the political level, there is a lot of competition going into 6G. I just happened to be in India 2 weeks ago at the ITU, World Telecommunication Standardization Assembly, which is a big event every 4 years. And at the same time, there was also India Mobile Congress, which has been growing quite a while. So there was an opening speech by the Prime Minister Modi, and he made very clear what is the ambition of India to lead in 6G, to lead with standardization. We later hear from Japan, from China, from the US, the research activities around the world, and all nations, of course, recognize the importance to have own contribution, own intellectual property, and of course having also the best hyper-connected infrastructure as we enjoying here in Korea. At the same time, it's also enormous to witness how India has changed. So we are blessed not only here in Korea but also in India to be a supplier of all three big operators. And one of the operators, so the 5G was introduced later than in Korea, which had the advantage that one of the operators directly went into standalone. So as we speak today, Geo is the single network in the world with the most traffic. So one has to digest that. Having surpassed the reigning champion of an operator in China recently, that just illustrates the magnitude of change. And they are monetizing 5G quite well. In India, it is fixed wireless access. When we then go to other countries, and in Korea, of course, there is no fixed wireless access because of the fantastic fiber optical access. But we see also customers now being able to offer more virtual private network offering. But the big question about how do I monetize my 5G investment is what we hear all the time when we talk to our customers. And indeed, depending on which companies, which operators and customer we speak around the world, some are not yet fully convinced about 6G. And that is where we indeed have to work on. So that's one of the thoughts I have. The other one, and I think it came up in several aspects of the previous two talks. So learn from your experience, learn from 5G experience. And one can take a couple of learnings. The one is certainly how we manage expectations. So who in this room thinks we did an outstanding job to manage as a community, to manage the expectation with 5G. So we saw this fantastic triangle from the ITU, and if I make a bit of an exaggeration, we made maybe believe that when the 5G networks were turned on in Seoul in 2019, everything was displayed on this triangle, would be there on day one. And then we realized, of course, that this was not the case. We basically had enhancement of mobile broadband. I said this is a bit of an exaggeration, but there is some truth, and certainly we have to make better in managing that expectation ahead of the 6G introduction. 6G is a success, 5G is a success, as both Ed and Juho also highlighted, but we suffer a little bit for having created too high expectation. What is another learning? Another learning is millimeter wave. Certainly, I can have a little bit of different perspective. And of course, Korea with US was one of those who were first. But one learning is we need to have a consistent service from day one, which is understandable from an end user, which is on a marketably enough area to be successful. So that we had like fantastic speed when there was a coverage of a millimeter wave on a mobile and we moved away, or there was a rain or leaf or whatever, and then the service what was not consistent to that level is difficult to understand by an end customer. And that certainly is one of the learning. Equally a learning is, and that's why there's a lot of focus on the mid-band, and I come to that also in a second, we have to be able to deploy the 6G network on the existing grid on day one. Later there can be densification, later there can be hotspot, but we must be able to deploy the technology on the existing base station grid. So that is certainly a second learning from millimeter wave, which made it, of course, very costly that you had to go with a densification, have then a service in a very limited area. So to me, that's a second learning. Third learning might be the simplification. So we had in the fantastic 3GPP standard, we had 6 versions, 6 variants, options, that's the word, between how to connect the radio and the core network between 5G and 6G. Of those, only 2 became reality, the non-standalone and the standalone, as we know. Most of the networks where we see advanced status of monetization from our customers are often have already moved to standalone. And the non-standalone is a challenge in that we got a bit stuck sometimes. So when talking to, for example, our customer China Mobile, they wanted to start. They are one of the first to introduce 5G, and they wanted to introduce from day one standalone, but they could not because the ecosystem wasn't ready. Would we have concentrated on this small jump to the new architecture? Would we have been ready maybe 6 months later? Would we have been then, as an industry, at a further state globally? My answer to that is yes. Of course, that necessitates a more radio-oriented migration. Later on this afternoon, my colleague Dr. Juk talks a little bit more about technology aspect, but also it was mentioned in the talks before, so there's much focus on radio-oriented migration technology, in particular multi-radio spectrum sharing between 5G and 6G, which allows then that we are deploying on the existing grid and having a continuous service and a good coverage. So that was also some view we had relatively late as an industry. We had a more, let's say, architecturally oriented view of the migration. Now we have a more radio and spectrum oriented view of the migration. So are all ducks in a row? I learned that this is an English term to say is everything prepared for success. So when we did 4G, I think those who did not have 3GPP wideband CDMA were clearly motivated to come out of the niche to enjoy the smaller ecosystem, to go out of the niche of the smaller ecosystem that had brought them in their respective market at a competitive disadvantage to competition. This is both true for TDS CDMA in China. This is both true for those who were deploying 3GPP to CDMA. So there was a lot of momentum to go to one standard, very business driven. In 5G, I want to remind there were sometimes moments where there was a risk of divergence. So there was a version of the standard based on test specification, optimized for millimeter wave, and there was the one or the other who thought maybe to move that into a more bespoke standard. Luckily, that was not pursued. Also, standalone and non-standalone, they had different timeline. There was a moment in time, I guess Juho knows very well, when we had to make sure in the community that the basic code, the ASN1, stuck together, so not having built a fork. A third example of that history is that later India, which I talked about before, entered into the process and had some ideas, and then at the end tried to promote that outside of 3GPP in a fork called 5G India. But also there, especially those more economic forces in India realized that this would have brought them at a disadvantage, and now we enjoy very much the plain 3GPP version of the standard in that country as well. So this example, just want to illustrate, just that we have nice pictures, and I have the same nice picture as before, which shows everybody is working happily in this dance between ITU and 3GPP, that we don't have that risk. And the risk may be on some of these technology components. We just I just had with Vanchi Kin a discussion around what is the level of innovativeness. So there is very different views depending on regions and customers on the level of innovativeness 6G should have. That is particularly a relevant question on the core network. Is it easy to migrate? Is it almost the same with is it a 5G core with a slight adaptation, or does it have some more significant changes that makes it proof for 2040 and allows maybe some opportunity for monetization and the convergence of compute and communication? That is a question where I see at the moment in the ecosystem a wide divergence. And we certainly have to work together to make sure that we have enough will to compromise. And that is, of course, easy to say no, but we will see when the work in standardization progresses and the hard questions related to these topics have to be decided. Nokia is certainly fully committed to work that we have a real one global standard also in 6G. So, and the fourth one, we cannot have a talk in 2024 without mentioning a little bit of AI. But I should explain that picture. Now it gets a bit more rich on material, every slide. So what you see on top is an AI application from San Francisco, which does creates images on natural language prompt. So you're asked to make a picture of a woman and of a unicorn, and it illustrates just from February 2022 to March 2023 in these 5 versions the dramatic evolution of the capabilities. You could, this is just because it's so visual, but you could take any other example, the evolution from ChatGTP 3.5 to ChatGTP 4.0 and the like. And below it's just illustrative what we showed before, what I show also next, the 3GPP timeline. So if I think, when we had 1G, 2G, 3G, 4G, 5G, of course, we always assumed there is certain capability by the electronics which can allow us to do certain things, to go from analog to TDMA, to CDMA, to OFDM, which was based on the assumption of miniaturization of electronics. And then these were all, like OFDM was a long-established principle, but we only know at this time it was right for commercial introduction in the system. So this is now, I mean this as an analogy. Here, how can we define a system which is based on a capability which is evolving so dramatically? And we have, to me, that's a real challenge. I don't have the concrete answer of that, but we have to what we understand can be done by AI today is very different than what can be done in 2029. Nokia is working with NVIDIA and SoftBank and T-Mobile on an AI-RAN analysis, AI-RAN alliance, which exactly works in that area. So here, indeed, this is the timeline you have seen before between ITU and the 3GPP, so nothing new. Right now, the work in the ITU is also quite key. I called this slide a little bit provocative, the geopolitical view of 6G. Those who go to the ITR, forgive me a little bit on doing that. So this is the performance view also, the technical performance requirement. Ed had this on the slide as well, which is now worked on in the ITR 2030 technical performance requirement. And that's in a decisive phase. Why I use this slide provocation is we have to make sure that the values are realistic. So if we use, let's take 2022 and throw this order of magnitude wider in each area, we might set requirements which are expensive to fulfill and have no commercial need. So that is related to some of the values that are discussed on spectral efficiency, on mobility, on speed of mobility. When there is no train who goes that fast, why doing that? On latency, we had 1 millisecond on IMT 2020. There is no real experience near or far on that latency. Why throw this now to 0.1 latency, and the same for reliability? So those of us who go to ITU, especially from the industry and other parties, I think we have to be realistic and not be based on the research, now putting in what we got from research, but also blend this to realistic values. Standardization will have to fulfill these values, and it can be quite costly. So this is now the alternative view on 6G, which some maybe find a bit more down to earth. So this is Nokia's view on technology components. Of course, that we have the extreme, I spoke on much of that, extreme MIMO on the existing grid, so no gigantic MIMO. That we have a smooth migration and a core evolution. I said here to discuss how much 6G will have capabilities which are non-backward compatible from 5G. That we have a programmable network and API native. One of the questions which I mentioned before that we see is the monetization. So we have to do things which facilitate that operators can monetize the networks. Native AI, energy efficiency, and one topic that is very clear, a requirement in many countries, and of course also in the ITU. One of the priorities is to make sure that we get connection where there is not yet a connection. So this is not always a non-terrestrial network. It's also the focus maybe on some lower FDD bands, but of course also the architectural integration in non-terrestrial networks. And here you see certain use cases that we see in the day one. Looking at the time, so this is sort of some of the technologies we see, is that we have a talk later this afternoon exactly on that, which I skipped. So on this question, are the ducks aligned? Do we have a regulatory environment which is appropriate to that? I also cannot avoid to emphasize the topic on spectrum. So we need 400 megahertz. I think Joe had that figure on his slide as well. And we believe we should seek for that at the upper mid-band. We said this is for network energy efficiency and for cost-effective update. We need to be able to build the network on top of our existing grid. So we have done some tests. You see snow, so this is somewhere near our headquarters in Finland, and you see the 3.5 gigahertz in the upper part, or 6, or just at 7.0 gigahertz. The antenna, same size with a larger element of antenna elements, and we are able to cover closely to the same area. So that is certainly possible. And here also I displayed in a different form than Ed did sort of the ITU status of the different regions and the different spectrum. Yes, in some areas it's upper part of 6 gigahertz. Sometimes I hear from the FCC that not everybody is so happy what was done, but maybe it's no point to hope that people will come back from a failure. But maybe if the decisions haven't been taken so far, maybe it is worth to consider whether to follow something which is considered maybe not fully successful in the US. Yeah, and we have to look very much on 7 to 8.4 gigahertz. Ed, in much more detail, explained the challenges on coexistence. So we will need to coexist in that band. So we need to be able to design the systems from 6G coexisting native. So that means that we also have to see that maintaining the paradigm that we have in the 3GPP system, that we are able to share with the incumbent user. Very quick, of course, I talked about simplicity, so and the different categories of devices. So here is just sort of our thinking on how we could have a modular design, which is then both with the control plane and then the more user plane, which allows us to have both a different level of devices, but based on a repeating paradigm. We also believe that there is a need, because of the timeline that these devices are in the market, to have a low power wide area component in 6G, sort of which we had with MTC in 4G, because those devices, meters and smart city elements, they are typically there for maybe 10, 15 years. So every second generation to have something which addresses the same capability is a wise thing to do. AI, so there are two elements. The one is that we have to design natively for AI and being also able to that we expose the data with intelligent controller and expose the data for monetization and for operations. And the second element is the traffic, which also is a big unknown. When we designed 3G back in the day, we had an idea of mobile broadband, but we didn't have an idea of how that was used. And it was used very different than we thought, but that also meant it was a very different characteristic to the network, much more interactive. And I believe the same is true for AI. We haven't understood the AI traffic, specifically the AI traffic of 2030, specifically those which are hybrid, sort of in between the device and the network, and the load that this will represent. And people come up with very useful applications if they have the right capability. So we believe that it will be one of the driving factor for the evolution of the traffic to 6G. So to conclude, so 6G will be built on the success of 5G. That means basically where it has its success and do in a more efficient, economic, and scalable and sustainable way. So that is certainly our vision going forward. There is a clear focus, certainly in my perception, much more than we had 10 years ago when we were discussing 5G, on the focus on the design, not only based on the research and the vision, but on the marketability. So, of course, scalable and sustainable and economic is the key here. Spectrum, I talked about. The design must be simple. We have to support AI in the system natively, and of course also AI as traffic will be key. Of course, energy efficiency is the big operating factor that we need to go down in the design, and my colleague will speak this afternoon. And we have to make sure that we have in mind how our customers are able to monetize that. And if we have these principles in mind, I am very confident we have one global, very successful 6G standard. Thank you very much.
Thank you for your insightful keynote.